right? This isn't enlarged, but that's the area where the earthquake heated that area. And so they're measuring the heating in the crust from the earthquake activity, and they recognize that it also had an effect on weather. So that's a unique discovery, and you'll see why that's so important as we go on here. So there's earthquake heating, and this is again showing spikes as this. This is spikes in the earthquake, and you can see the spikes in the earthquake were also followed by hot springs water flow rates increasing. Right, the big blue one up there, and you can also see it's fluctuating in air temperature as well. Okay, so you see how those are all kind of coordinated. And so the earthquake activity is having an effect on weather. And the reason that's so important is because we're creating a new water cycle. Traditionally, the water cycle, we were all taught in grade school, is the idea that the sun heats up the oceans and creates clouds, and then those clouds move over the continent and drop the rain, and that flows down the rivers out to the ocean, right? That's the water cycle that we're taught in elementary school. But does that tell the whole story? And the answer is no. In fact, but if you look at it, the sun is the only source of heat and the only source for weather that that whole model and that modern science has for where weather comes from. Okay, so the highs and lows, high and low pressure zones and stuff, all comes from the sun. But does the sun change? Not really, right? I mean, it goes around the earth, so we have hot and cold cycles from day and night, right? But other than that, the sun is pretty much constant all over the surface of the earth. Um, and so we've got to look at this because the old water cycle here has the sun as the only source of heat, which means that it's the only source of changes in the weather. So it's no wonder that scientists today are who are trying to calculate the weather and figure it out are confused and are saying things like, well, maybe a butterfly's wing flapping in China is going to cause a tornado in Texas. And they're writing books about chaos because they look at weather and it's all chaotic and they have a hard time predicting it because they only have one source and that source doesn't change very much other than going around the earth. So where are we getting all this weather from? And this model doesn't explain it. So vaporization is only a slow process, right? But the universal model presents a new new water cycle, and it's because hypothermal processes create new storms and weather patterns, and that's because there's earthquake fault lines that are actually heating up the ground all over the earth. Even here in Arizona, if the ground's going up just a foot, right, that may not be very much, but with thousands of pounds of pressure, that's a lot of frictional heating. And so you have clouds popping up in the middle of the desert when we don't have lakes and streams and rivers and stuff for the water to evaporate from. We certainly are a long ways from an ocean. In fact, you can look at the satellite maps and you can see it's not blowing, those clouds aren't blowing in. We can see them forming in the desert, right? Billowing up, these billowing clouds. And that's coming from hypotherms. So water quakes, heat, right? So they call them hypotherms, which is the endovaporization, which can be a rapid process. All right. So this endovaporization is a rapid process because that frictional heating is happening fast. and it doesn't have to be a great big earthquake to evaporate some steam from even here in the desert, so that these clouds pop up quickly. And so by adding this additional source of heat, then with the sun, you get a lot of action, and you can create a lot of weather patterns. So I think it's pretty exciting and makes a lot of sense. Yeah, I want to teach it to the weathermen, because they actually have the pressure flipped around. So here's the 3 new laws of weather. Earth's weather is changed by hyquotherms. Hyquotherms are changed by gravitational astronomical cycles. And you notice weather, like even monsoon season that we're in now, right? The storms tend to happen around the same time of day, right? The clouds pop up in the morning, right? And we have some rains at night, right? So gravitational astronomical cycles, we notice that. Earth tide and atmospheric pressure and the geofield are directly connected through gravitational astronomical cycles. So another thing that's presented in the weather model, although not in this chapter, is that it's not a magnetic field. We call it a geofield, because it's actually energy. Like if you think of a electromagnet, right? Electromagnet is created by electricity, right? Well, quartz crystals that are all over the surface of the earth, they generate electricity when you put them under pressure. They generate electrical power. So anyway, so we call it a geofield, that's creating what some people say is a magnetic field. All right, so we have high pressure systems, the H's you're familiar with, and low pressure systems, the L's that you see on these maps. The importance of atmospheric pressure to the Earth's weather cannot be overemphasized. And so weathermen always talk about these high and low pressure systems, but the question is, where do they come from? How do they form? Especially if the sun is the only source of heat. But if you have earthquake activity, frictional heating happening all over the crust of the earth, then it makes a lot of sense that you're going to have some steam being produced. And if you have steam being produced, then it's expanding, right? That water, what was water down inside the earth, is expanding into steam 1,700 times the volume. And so that steam is now getting spread out from inside the earth and kind of exploding. Not enough to blow a mountain off the top, but just seeping up through the sand or the dirt or little cracks in the earth, and expanding, and it's growing and making a high pressure system. And then that's going to go over to the cooler areas where the low pressure is, right? And so the meteorologists have it all backwards, because they say the high pressure system is air pressure pushing down from above, and we're saying that the high pressure is the heat evaporating the water, turning to steam, and so it's expanding from below. Okay? So high pressure is expanding in all directions, and the low pressure is where that hot steam is going to, because it's cooler. Okay? So yeah, this is what the meteorologists need to know. And so if you think of this, if you think of the hot balloons as hot air that's expanding, and the blue balloons as contracting low pressure areas, right? You're going to get that balance of these highs and lows, right? Because this high is going out this way, and where's it going to go? It's going to go over to a low place, right? where it's cooler, where it's decreasing in size. Okay, so that's a balloon experiment. And here's one where we actually did it with ice on one side and incense burning on the other side, so you can actually see where that heat is going to and traveling. The high pressure areas expand in all directions, and the low pressure areas contracting from all directions, right? So here, expanding in all directions, right after the hot water was removed, the steam was rising, right? So the incense is just to create enough smoke so we can see which way the air is moving, flowing, right? But the hot water steam rising and expanding, and it's all going towards the other side because that's where it's cold and can condense, right? And we see condensation on a cup of ice, right? That the steam from the air will condense onto it. Well, that's because that's where it wants to move, because that's where it's cool. And the hot water molecules are trying to get away from each other, right? They're moving so fast. Okay. So that concludes my presentation. Did you have any questions on the weather? Okay. Then, and if you want to see that thing about the water, the underground lake or ocean that they found on Mars, you can go to Do True Science on Facebook, and you can catch that. If you want to see these type of presentations that I give each month, you can go to my YouTube channel, which is also called Do True Science, and you'll see experiments that I do with the kids at the school here. And I want to give a special thanks and shout out to Michael Belknap for video recording me today. Thank you, Michael. And you can go to universalmodel.com to find out more and get the book. If you do want to buy the book, when you go to the store and you're checking out, there's a place for you to enter discount codes, and you want to use the code Do True Science. That'll give you a discount. Actually, just Do True. Don't want to make it short for you. So just the first two words of my Facebook and YouTube channel. But anyway, thank you all for coming. I really appreciate it. I hope you enjoyed it and got something out of it. And if you have any questions, you can come on up and ask me. Thank you. All right. Appreciate it.